Hello, everybody. I'm Laurie Voss. I'm VP of Developer Relations at LlamaIndex. In a former life, I co-founded NPM Inc., so some of you may remember me from when I used to talk incessantly about JavaScript. Now I talk incessantly about AI. Either way, I talk incessantly. Today, I'm going to be talking about RAG and agents. RAG, for those who doesn't know what RAG stands for in this room? Or rather, raise your hand if you do know what RAG stands for. That's easier. OK. So about half. RAG stands for Retrieval Augmented Generation. So first, I'm going to introduce you to LlamaIndex, and then we'll cover the basics of RAG quite quickly, because most of you seem to know what it is. And we'll talk about why we need agents and how to build those in LlamaIndex. And finally, we'll talk about workflows, which are the latest feature of LlamaIndex, released just a few weeks ago. So what is LlamaIndex? Hands up if you've heard of LlamaIndex before. Oh, that's nice, too. OK, cool. But it's a bunch of things. The bit that you probably heard about already is that we are a framework. We are an open-source framework in Python and TypeScript for building Gen AI applications. But we are also a bunch of other things. We have a service called LlamaParse, which is part of cloud.llamaindex.ai. It is the best PDF parser in the world, in addition to being the parser for Word docs and PowerPoints and like every other kind of document that you can possibly imagine. This turns out to be one of the hard problems of building generative AI applications, is that you have all of this data, and your LLMs are very clever, but the LLMs don't understand what they're reading. And a really good parser that knows that the purpose of parsing is to make things more readable for LLMs turns out to be a huge leg up in building a RAG application. We also have a thing called Llama Cloud. If what you want to do is just stuff documents into one end and get retrieval augmented generation out the other, then it is the service for you. You can think of it as LlamaIndex building a LlamaIndex application on your behalf. It's an enterprise service, so it is costly, unlike the open source part. But if you work at an enterprise, sometimes the right thing to do is just say, let's slap down a lot of money and not spend any time figuring out how to get this right. And then there's Llama Hub, which is our registry of helper software. If you need to connect to any database in the world, we've got you. We have connectors that will help you do that. Do you need to get your data out of Notion or Slack or Salesforce? We've got connectors that will help you do that. Do you need to store them all in a vector store? We connect to every vector store that exists. Do you need to then need to send that information to an LLM? We integrate with every LLM that exists. That is basically the selling point of LlamaIndex, is that we have already integrated with every third party that you could possibly imagine, and figured out how to connect them all to each other. So you just pick your from your menu of third parties, and we will put stuff together for you. Which is why you should use LlamaIndex, because you're a developer and you have limited amounts of time and you have actual business problems to solve. So don't get stuck figuring out the basics. We've solved a bunch of the foundational problems for you, and that is the purpose of the framework, is to let you get on with the thing that you want to get on with. So enough of the sales pitch. Let's talk about what this framework can actually do for you. I mentioned retrieval augmented generation, and I mentioned agents without explaining what either of those things are. So let's fix that now. Most people already raised their hands, so I'm going to go quickly through this. Retrieval augmented generation it's a response to a fundamental limitation of LLMs. They are trained on they are trained on mountains of data, but they aren't trained on your data, because your data lives on your computers behind your firewall, and they can't get to it, thankfully. So to answer questions about your data, you have to give them your data, but you can't give them all of your data at once. They have limited context windows. They can't absorb, and it would be ridiculous if every time you wanted to answer an LLM to answer a question, you gave it like your entire backlog of every PDF your company has ever produced. That would be a crazy way of doing things. So you have to be selective. You have to select which documents in your database, in your collection of all data, are going to be the most relevant to answering the question. And that is the tricky part of the retrieval part of retrieval augmented generation. You have to select data that is semantically relevant to your question. So using technology related to LLMs called an embedding model, what you do is you convert your data into arrays of numbers called vectors. The total set of available vectors is referred to as vector space. So converting your words into these vectors is known as embedding them into vector space. And so the results are called embeddings, which I think is a ridiculous name because it's like 3 degrees of indirection away from the thing that you actually did. But anyway, you turn all of your words into numbers, and then the clever part is that you take your query and you convert it into numbers in the same way. And then in vector space, your query and the answer to your query end up mathematically nearby to each other. You can do relatively simple math across all of your numbers and say, give me the numbers that are close to these numbers, and that will magically be the data that is most relevant to your question. You then retrieve that information, turn it back into text, feed the text and your query to the LLM, and the LLM is able to answer this query using relevant data to your query. So that is the theory of RAG in 30 seconds. Let's talk about how you build a RAG pipeline in practice. You have to ingest your data. You have to parse it into chunks. You have to embed those chunks. You have to store those chunks in a vector store. And then you use a query to perform semantic search on the chunks that are in your vector store. You take the chunks that you retrieve and you give those chunks to an LLM to answer your question. That's a lot of steps. Let's look at each step in LlamaIndex. This is the loading step. It's a one-liner. You tell it what direction. If all of your files happen to be just sitting there on disk, it's a one-liner. You just say, OK, give me all of the files that are in this data folder, and I will turn them into documents that are pre-chunked and ready for LlamaIndex to use. The next step is parsing. As I mentioned, LlamaParse is a really useful tool in this area. This is how you use LlamaParse to do that. It can convert any type of document, really any type of document, hundreds and hundreds of types of documents, into either Markdown or text. It turns out that LLMs are uniquely good at understanding Markdown because they're trained on so much Markdown. And next, you have to embed your data. Again, this is a one-liner. You just take your data and say which model name you want to turn it into. In this case, we're using a local one, but you can use OpenAI or any other remote embedding model that you want to. And once your data is embedded, you have to store it in a vector database. In this case, we're doing it, again, with a one-liner. But we integrate with every vector store that exists. So even when it's Chroma or Quadrant or some other vector store, it's, again, only a couple of lines of code. To use your embedded data, you have to query it. LlamaIndex will embed your query, find relevant chunks in your vector store, and return those chunks for you. This is what that looks like. You can then do stuff to the chunks you've retrieved, like re-ranking them for greater relevance, because your retriever is completely customizable. And then usually what you want to do with the relevant chunks of data that you've retrieved is send them to an LLM. And this is what that looks like. You turn your index that you created earlier into a query engine, and you give it a query. And it takes care of all of the work necessary to get that done for you. If you're paying attention, you'll notice that we did all of this in 5 one-liners in a row. 5 lines of code is all you need to get from one end of a RAG pipeline to the other in LlamaIndex. That is the selling point of our framework, is that it is so easy to get from one end to the other, although at any one of those lines, you can turn it into more lines of code to customize it to do exactly what you want it to do. We can do all of this stuff for images as well. We don't just do it for text. And if what you want to do is create a chatbot over your data, which is what an enormous number of people want to do with their data, you do not have to build one yourself. We have a one-liner called npx create llama, which will generate a web app that looks a lot like this. It will index all of your data, it'll embed it, it'll query it, and it'll give you a nice chatbot that gives you all sorts of fun features, like quoting its sources and stuff like that, that takes a long time to build if you're building it yourself. But the point of this talk, all of this talk so far, is that there is more to the problem of context-oriented applications than just RAG. RAG is simple. I just showed you how simple it was. We can do it in 5 lines of code. That's not all there is to solve the problem of doing a retrieval, of doing a context-augmented application. There are a number of ways that naive RAG, the kind of RAG that I just showed you, can fail. One task it's not great at is summarization. By definition, what it's doing is it's trying to retrieve chunks of your documentation and summarize those chunks of that documentation. It's not trying to summarize your entire document. It's not trying to summarize everything in your corpus. So RAG is just not good at answering questions that are about summarize the state of the world. It doesn't have that. That's not what it's designed to do. Another task that's tricky for strictly search-based RAG is comparison. If you've got a bunch of data about multiple people, for instance, you can ask it a question about, compare Bob to Susan, but it's going to try and do that all in one shot. It's going to retrieve a bunch of chunks that are about Bob and a bunch of chunks that are about Susan, but it's not going to tell you which ones of those are which, so it's going to end up doing weird things, like attributing parts of Susan to Bob and vice versa, simply because you can't do all of that in one step. And more generally, multi-step questions is where RAG tends to fall down. If you are trying to get your pipeline to summarize the arguments of article A and the arguments of article B and compare and contrast them, it's going to do a very bad job at that unless there happened to be a summary already there in your data that it could retrieve. Which isn't to say that RAG is useless. Naive RAG is extremely useful. It's an extremely powerful tool, but it's a tool that you have to embed into a larger and more complex application. So what do we do? How do we go beyond these limitations to build an application that can solve all of these problems? There's two avenues of improvement that we can follow. The first is to improve the data quality, and that's one of the reasons that we built LlamaParse. Getting better data out of your documents in the first place can demonstrably improve the quality of the results that you get from your application. But the second way is to make your querying more sophisticated, and that's what I'm going to focus on for the rest of this talk. So a naive RAG pipeline has a bunch of limitations. It's single shot. There's just one question and one response, like I said. There's no query understanding. It's just semantic search. There's no tool use. You can't go and seek out more information to answer questions that you can't find the answer to in your documents. And there's no reflection or error correction. If your RAG does a bad job or comes up with nonsensical results, it just returns those to you without thinking any further about it. And finally, there's no memory. Every question is brand new with no memory of the previous context in which you asked questions. By building Agentic RAG, you can do a whole lot better than that on every front. You can have the agent understand the question and plan how to get the answer in multiple steps. You can make RAG just one of many tools available to your agent to be able to answer these questions. You can use reflection to figure out if the response is adequate and course correct if it's not. And you can have memory so that each question that you ask becomes part of a larger context towards completing your goal. Getting all of that done is a lot of work, but it is work that we put together in LlamaIndex for you. The strategies that I'm talking about here exist on a spectrum from simple to complex in terms of how difficult they are to implement and also how slow they are. Because generally speaking, the more complex they are, the more round trips, the more work the LLM has to do. So it's not just a home run to just go and let's do the most complicated thing imaginable and answer the question, because sometimes your application is going to be time sensitive, you're going to want to reduce your latency, you might want to do something simpler. Let's break down all of these one by one. The first step is routing. This is the simplest form of agentic reasoning. Given a query and a set of basic tools, what the router does is select the best LLM to answer the question. This can solve the summarization problem by making one of the available tools a summary of the entire document or the entire document to be able to feed to the LLM for it to do the summary for you. This is built into LlamaIndex as the router query engine. This is an abbreviated version of how you do that. What we're doing here is we're creating a pair of tools. One is a query engine, and one is a summary query engine. And you're giving both of them to the router query engine and letting it select on the basis of what the question is, which of these tools is the best one to answer the question. It's still one shot, though, so we can do better than that. The next tool that we can add to build up an agent is memory. This is theoretically simple. You run queries, and you add them to a history of all of the queries and answers that you've got. It can get complicated, though, as you begin to exceed the boundaries of your LLM's context window. You have to start taking your history and condensing it intelligently so that you are not overflowing your context window with your queries every time you ask a new question. And again, this is built into LlamaIndex. It's as simple as changing from a query engine to a chat engine. and we take care of all of the complex memory stuff for you. Then we can add one-shot query planning. What this does is it takes a complex question and breaks it up into simpler questions, each of which can be run in parallel. You can then take the resulting responses and combine them, or rather get the LLM to take those responses and combine them to produce a single coherent answer based on the answers to multiple queries. The built-in here, there's a built-in for all of these, is called the sub-question query engine. What I'm doing here is passing in, again, a tool, just one tool in this case, about a Paul Graham essay for some reason. And you give all of your tools to the sub-question query engine, and it treats those as sources of data that it can ask multiple questions to. The router query engine and the sub-question query engine are two examples of the biggest part of making Agentic RAG effective, which is tool use. Tool use allows you to describe an arbitrary API and give it to your LLM and have the LLM use that tool to perform actions. Those actions can be data retrieval, or they can be changing the state of the world. They can, you can call a calendar API and get it to create a calendar event for you, make a phone call, send some voice, whatever you want it to do. Tool use doesn't just have to pass the query, it can adapt the query to the tool. So, for instance, in auto retrieval, it can take the query and uses it to decide how to pre-filter your data based on the metadata that you have available. So if, for instance, you have a bunch of documents from multiple years, it can go, this query is about 2021. Let me filter down all of my documents to documents from 2021 before I start searching for relevant information inside of them. If you're talking to a SQL database, a tool can transform your query from natural language into SQL, that kind of thing. You've already seen examples of tool use in LlamaIndex. I was showing them to you in the sub-question query engine and the other engines. But your tools can be arbitrary Python. In this case, I've created one that is just multiplies two numbers together. Your tools can do literally anything as long as you describe what they do in your doc strings. And the doc strings are used by the LLM to figure out what it is that this tool is useful for and what I should do with it. You can pass as many tools as you want, and you can really go nuts and do very powerful things by providing your LLMs with tools. So now we've seen the basic agentic strategies. We've seen routing, memory, planning, and tool use. But we can go further. Let's make our agent multi-turn. Let's give it reasoning and planning. Let's give it reflection. And let's talk about how we get all of those things done. There's three types of agentic reasoning loops that I want to talk about. Sequential, DAG-based, and tree-based. These also live on a spectrum, just like the previous techniques, from simple to complex and from cheap to expensive in terms of computing. The first is sequential. What this does is you generate your next step from your previous steps. It's sometimes known as chain of thought, and one of the most popular patterns here is called REACT, not the web framework, but REACT as in reasoning plus action. We already saw it demonstrated when I was showing you tool use. In REACT, the agent demonstrates, the agent produces this distinctive pattern of making an observation, having a thought about that observation, and deciding what action to take as a result of that observation and that thought. It stays in a loop, coming up with thoughts and observations and actions over and over until it achieves the goal or it gives up. You can see this in action in this output. I told it to multiply two numbers together, and it thought, how do I do that? I have a tool. Let me use the tool. Let me add multiply these numbers together, then add these numbers together and come up with the answer. And that's the basic agent loop. The next step up in sophistication is a DAG. In this case, a DAG is a directed acyclic graph, which means, like a flowchart, basically. DAG allows planning. It allows you to take allows your LLM to come up with a series of actions that it intends to take from 0 to completing your goal. A critical part of this planning is the ability to replan if the steps that it originally planned don't work. It can say, okay, I planned this set of steps, they didn't work out for me, I can change what my steps are, and come up with a new plan. This ability to self-evaluate is called self-reflection, and the LLM can do a relatively good job at figuring out whether the LLM is getting you towards your goal. Once again, doing this in LlamaIndex is simple. We've created here 2 tools in advance, so you're not seeing the code. One of them is a set of documents about Lyft. One of them is a set of documents about Uber. We provide these to a function calling agent worker, and we create an agent from them. And then we ask it to do, in a chat, we ask it to summarize the key differences between Lyft and Uber in terms of their risk factors. It can do that because it'll do these multiple tools in multiple steps and come up with a plan to do that. You can see here what the output of that looks like. You can see that it is come up with 2 initial steps. One is to summarize the key risk factors in Lyft, one is in Uber, and then you can see the 3rd step is to combine those 2, and that those steps depend on the output of the previous steps. This DAG can be arbitrarily complicated. It can have as many steps that depend on other steps as it needs to be able to get to the goal. But still, DAG-based planning works best when the task is simple enough that the LLM can figure out how to get from one end of the task all the way to the goal in one shot. Most real-world tasks aren't like that. Most real-world tasks, you don't know in advance how you're going to be able to solve the problem. You just have an inkling of what might be the next useful thing to do. So here you get to tree-based reasoning. There are several different variants of this, including tree of thought, reasoning via planning, and language agent tree search, which is the one that we built into LlamaIndex. But they have some fundamentals in common, which is that they don't know in advance how they're going to get there. They just know that they can build a plan. Instead of building a single plan from start to finish, what they do is they come up with a series of possible things that they could do and start exploring a tree of possible actions from each of those actions that it takes. And it executes them all in parallel and figures out which of these branches of the tree is getting me closer to the action that to the goal that I'm trying to get to. A good question is, how does it know that it's getting closer to the goal? Well, you can give it an external function that says, okay, yes, this is how you measure whether or not you're getting close to this goal. Or you can, again, just get the LLM to try and figure it out. Does this branch look like it is closer to the goal than this other branch? And ask the LLM to figure that out. As they go, they will expand various branches. They will go down the branches a certain number of steps before deciding that this branch is not going to work out for me and abandoning that branch. That process of branching out, exploring, and then pulling back out is called the balance between exploration and exploitation. Like I said, one of the strategies for doing this that we implemented in LlamaIndex was language agent tree search. As you can see again in LlamaIndex, it's just a couple of lines to get that going. The parameters here, number of expansions is how many branches it's going to create, and the max rollouts is how far down the branch it's going to go before deciding whether or not this branch is a promising avenue to explore. So now we've got pretty deep into LlamaIndex. We can build a RAG pipeline. We can build agents that use RAG pipelines. The last thing I'm going to cover today is workflows, which allow you to build on these patterns to create more complex applications. Why do we need this extra feature of the framework at all? Well, we are growing along with our community. We discovered that while putting together a simple demo over a small number of documents can be done quite simply using the framework, when you start putting together an application that has a whole bunch of steps, a whole bunch of possibilities, a whole bunch of work that it has to do, it can get hard to keep track of all of the steps and all of the things that are going on. And this is our response to that need. This is how you grow your application from your initial demo to a real production application. So we don't expect this to be the first thing you reach for when you're learning LlamaIndex, but we do expect that it's going to be a thing that you need. So the most basic workflow looks like this. So workflow is composed of steps, and you can have as many as you want. So you create a class that holds all of the steps. The steps are marked with that step decorator. And they use type descriptions to define how your steps are executed. So by definition, if you are accepting a start event, you are the start of the flow. And if you are emitting a stop event, as this one is, you are the end of the flow. In this most basic example, we have just the one step. It starts and it stops all in one flow, and it does one thing in that time. So this flow just runs linearly, but you can use it to define a loop, for instance. This is useful for self-reflection. You see in this example, we have two steps. The first accepts that start event, and it tries to answer the question. In this case, I'm using random numbers to simulate whether or not it answered the question correctly. And if it gets a bad answer, it emits a failed event, and that triggers the improve step query, which will try to come up with a better query and emit a query event, which then gets picked up by answer query again. If it answers the query correctly, it emits a stop event, and if it can't improve the query, it also emits a stop event. So all of the possible flows are visualized here in this diagram. And this visualization tool is also built into LlamaIndex. You can just call draw all possible flows like that, and it will draw this diagram of what your flow looks like, which is a very useful tool for planning and debugging. In addition to passing events around, there's also a global state that all of your steps share, so that you don't have to be constantly passing all of your data from one step to the other. You can see here we're calling simple directory reader, and just like we did in the 5-line starter that I showed you at the beginning. Whoops. And now my beautiful screensaver. And we're assigning it to a variable called index, which makes it available to every step in the flow. So these steps, these workflows that I've showed you are very simple because they necessarily have to fit on a slide. But you can define arbitrarily complex flows using these steps, and this event-based pattern we think is very powerful for not having to come up with a complete DAG of everything that your application needs to do in advance. You can just come up with what is the next sensible thing that this application would do and emit an event that does that. So like I said, as your flows get more complex, we think that this is the tool you're going to reach for. As workflows mature, like I said, we released these only a couple of weeks ago. We're going to be releasing pre-built flows that you'll be able to hook into and extend. The 5-line starter will become a 1-line starter. You'll just call that workflow, and you'll be able to extend your steps as you go. This is showing how that's done. It's done with a sub-workflow built by a subclass. There's a link at the bottom there, and you're also going to get all of these links at the end of this talk about how to build a full workflow. So now you've been all very patient. Thank you very much. I just have a couple more things to handle. One is observability. As your application gets more advanced, you're going to want to have observability to check on all of the state of your application as it develops bugs and as it runs. We have integrations with a variety of third-party observability tools like Arise Phoenix, which give you full tracing in any LlamaIndex application that you are building. And the second is evaluation, which is a whole talk by itself that I'm not going to give now. Evaluating your app, measuring whether or not it's doing a good job, is essential to building a professionally built generative AI application. At small scale, you can just use vibes, and that is what a lot of people do. Like, does this feel like it's giving me the right answer? But at large scale, you're going to want like a formal way of measuring whether or not this thing is actually doing what it said it would do, and that is where formal evaluation comes in. So this is all of the stuff that I've covered in this talk. I'm not going to say it all out loud, but it's a whole bunch of stuff. We covered all of these things in 30 minutes, so we covered them all pretty quickly and at a very low level, but what I'm hoping this talk gives you is a sense of all of the possibilities that this framework allows you to do, and also a sense of why you'd want to do those in the first place, why you would want to solve a generative AI application by building agents that use tools. What happens next is up to you. We are very excited to see what you can build with all of this. We are an open source framework, and we live on feedback from our community. So feel free to join our Discord via this link. Our engineers hang out there all day and answer your questions in disturbingly short time when they should be working. So we also have extensive documentation. Like I said, I linked to it earlier. I pour my heart and soul into that personally, so I'm very interested in getting your feedback on the documentation as well. And I hope this has been a useful introduction to you. If you follow this QR code or that link at the bottom, you will get a link to these slides, plus all of the resources that I linked to today elsewhere in the documentation. And it's been a pleasure to speak to you. Thank you all for your time and attention.